Good evening, welcome. I'm Nick Bonner with TreeStuff.com, and we're proud to bring you a webinar this evening about carabiner inspection and maintenance. I'm here in Indianapolis, and Taylor Hamel, technical representative from DMM, will be walking us through tonight's material live from his living room somewhere in the woods of Minnesota. Taylor's been working for DMM as long as I can remember, and is probably the world's foremost authority on hardware and rigging. So we're incredibly lucky to have him. I, of course, want to thank our whole crew here at TreeStuff, Jake, Carson, Kale, for planning and executing this stuff, working on the technology side. Big thanks to the ISA. We've got CEUs again tonight. So we'll have 2 CEUs available for you at the end of tonight's broadcast. There will be a quiz. The link will be posted in the comments for this post, as well as a second post on the TreeStuff Facebook page, so you can check that out. I think I thanked everybody. Let's take it away. Taylor?
Oh, hi. I didn't see you come in. I'm just doing a little light reading, sitting by the fire. Welcome. Well, I'm here to talk about carabiners. Thanks for coming. We'll do a little chat here by the fireside, and then we'll move into the kitchen where the real work begins. Anyway, today, this evening, thanks to TreeStuff.com for putting on this webinar. I'm very excited. Thanks to DMM, who I work for. And I'll give you a quick rundown about what we'll talk about over the next hour and a half, just about 2 hours or so. And that'll be carabiner inspection, carabiner maintenance, cleaning, lubrication, a few details about carabiners, and maybe some things you didn't know about the manufacturing process, that whole thing. So while the title might not be the most exciting webinar title, we'll get into some cool stuff, and hopefully you'll learn something new. I believe we'll be taking some questions, some online questions that'll be relayed to me through the earpiece from TreeStuff. So let's get started, huh? When we talk about carabiners, I suppose we should talk a little bit about nomenclature, the different parts of the carabiner. And obviously there's 2 different carabiners here. We'll get into carabiner shapes and how that determines how a carabiner behaves, strength and different attributes. Some carabiners are small and compact and good at some things. Other carabiners are larger, have a larger gate opening. They're better at other things. So generally one carabiner can't do it all. And it's important to know the difference where you might want to apply each carabiner for a particular situation. So very quickly, we have the frame or the body of the carabiner. That's the aluminum or aluminium body, depending on what part of the country you're in. We also make steel carabiners. These are going to be aluminum for this demonstration. Most of us are familiar with the spine of the carabiner. That's this portion here. We have a gate. What rotates around the gate as a locking mechanism, we would call that the barrel. We have the carabiner nose. We have the hinge or the hinge rivet pin that goes into the hinge that holds the gate in place. And there's some different internal mechanisms in the gate. We'll talk about that later as well. So, okay. Carson's telling me I might need to go over that again. I'll bring this up a little closer to the camera. How's that? So we have the carabiner frame or the carabiner body. Are we doing okay there, Carson? You see that a little better? Okay. So this is the spine of the carabiner. When we talk about loading carabiners along the major axis, we're loading them along the spine. We have the carabiner gate, which is what opens and closes. the locking mechanism, or the are called barrels. So this has two barrels, this Duralock carabiner. We have the nose of the carabiner. We also have the hinge, or the hinge rivet pin, and that's what holds the gate onto the carabiner body or frame. So we'll talk a little bit more about that later when we get into cleaning. All right. Let's head into the kitchen and start our work. All right. You might get dizzy. I'm going to move the camera, so hold on to your shorts. No, sorry, no tour today, but the kitchen's nice. I'm going to do my best to set this up in a... We're just working on the fly here, so bear with me. Try to get in close to the table here. Going up. Looks good, Carson? Cool. Okay, so just going over what we'll cover. I'll try to be in frame here. Try to get the computer out of the way. Pardon the noise. Yeah, that's pretty good. So, we talked a little bit about carabiner nomenclature, the different parts. We'll talk about loading. We'll talk about some serial numbers and different applications. We'll talk about standards very, very briefly. We'll talk about carabiner shapes. Then we'll get into the internals of the gate mechanisms. I have some special cutaway carabiners here. We can see the internal springs and how they function. And then we'll get into carabiner inspection. We'll have a few PowerPoint slides to look at that we'll queue up, and then we'll move over to the kitchen sink, and I'll actually clean a carabiner, dry it, and lubricate it like I would normally, so you can see how that process goes. And then we'll take questions along the way. So, carabiner shapes. Very popular Ultra O carabiner. I'll hold that up closely. A symmetrical oval locates the connection. What you're connecting to locates into, I guess you could say, the top and the bottom of the body, right? So it's sort of centralized in between the gate and the spine. Something like this Zodiac, for example, is quite a bit differently shaped. It's got sharper corners here, if you will, so that locates the attachment points, or locates the pins, if you will, very close to the spine. And that plays to the strength of that spine. This shape is a very strong shape, but it doesn't allow us the same kind of connections that we would use with an oval carabiner, for example. A good point there is, for example, in the hitch climber system. Can you see this all right, Carson? Just double checking. Okay. Sure. Closer I get to the camera, the better. So here we have a hitch climber system. We've got our hitch climber and two eyes of hitch cord, and those sit very nicely in that oval carabiner. That oval carabiner does a great job of housing that material in such a way that benefits. What am I trying to say here? It benefits everything. It plays to the strengths of that carabiner, keeps everything nice and organized. For example, if I tried to do that same thing, I'll just switch it out here with the Zodiac. Okay, that's not nearly as favorable. What's happening here is I've got part of the load right next to the spine, and the other parts of the load get pushed further away from the spine out toward the nose. And when you load closer to the nose, you wind up reducing the braking strength of that carabiner. So in this case, this would not be the best choice of carabiner in this application, where an oval is a very good choice. We'll tidy this back up. Any questions so far, Carson, or we just keep going along here? Cool. Sounds good. All right, we'll set that aside for now. So a few other carabiner shapes. We have some quite small and light rock climbing or quick draw carabiners. That's simply just a wire gate, super light, but also the shape that puts the connection points and the rope. So your quick draw point here, quick draw sling, rope here, naturally wants to push it toward that spine where you get the most strength out of that connector, out of that carabiner. We have some other interesting shapes, miniature HMS. We have a wider top for perhaps belaying, putting a munter hitch in. You need some more space up top. Also a wider gate opening. That's another important aspect of this design with the sort of offset spine there. Where again, if we go back to the Zodiac, very strong, relatively compact, but slightly smaller gate opening. And none of it's good nor bad, it just is what it is. And depending on the application you're using the carabiner for, you might choose one over the other. Again, shadow, nice and lightweight, puts the loading points toward the spine, which retains that minimum braking strength, MBS, that'll be on the test. We also have, I should talk about different gate styles. For example, we have a plain wire gate, very simple, very easy to manufacture. It's simply just basically just a bent wire that's offset here at the connection points in the hinge, so it's spring loaded. And you start to get more complex. For example, our straight gate. This happens to be a Perfecto, but this simply has a spring body of the carabiner, the gate itself, and the internal mechanism would be the compression spring and the little plastic spring pusher. So that again, just one step up, slightly more complex. Oop, going in the wrong way. You can tell I don't work in final assembly. Right, so when that's assembled, it's simply just a spring load that way. Screw gate carabiner, same idea, simply a gate with the spring and spring pusher inside, and then a screw gate mechanism to lock it in place, to lock the gate closed. Right now, for our use in the arborist world, we typically use a triple action gate mechanism, which is 1, 2, 3. Right? There's 2 separate actions to prepare the gate for opening, and then you open the gate. 1, 2, 3, triple action. Or you would, in some places, they might call that double auto locking. But in any case, we're all familiar with that. And this DMM gate style is called lock safe. Triple action is called lock safe. We also have a Duralock somewhere. Oh, right, it's in my pocket, I think. Well, I put it somewhere. Anyway, I'll show that a little bit later. Also, we have what's called an Ansi gate, right? And this gate, you can see it's quite a bit larger. It's more bulbous at the nose, and that's because that has to withstand 16 kilonewton force on the gate. So that's we have a slide up there. I can talk about it later, but this will resist 16 kilonewton load on the gate, pushed inwards, pulled outwards, and also a side load on the gate. So we'll show some of that testing, some of that imagery a little bit later. Carson, are you still with me? Okay, we're doing well. Just let me know. All right, Carabiner Shapes. We did some gate mechanisms. Let's keep moving along so nobody gets falls asleep here. We looked very quickly at some of the internal moving parts of the gate mechanisms. Let's look a little more closely at that. And we'll start out, of course, with the spring pusher that I probably lost now. All right, so we've got a little compression spring here. That would load into the gate. And there it is. I remember I left it in. So the spring pusher gets inserted into the compression spring. Compression spring and spring pusher get pushed in and located in the gate itself. And then that spring pusher, when it's in place, if you can see, it rides against this little detent at near the hinge point there, the hinge rivet. And when that is pushed down, it compresses the spring and it'll load back, spring back into place. So you've got a cool cutaway here I had the engineering team do for me. Am I close enough there, Carson? I'll get even closer. Everybody see that? How does that look, Carson? Okay, so we've got our hinge pin in place, or rivet pin, if you want to call it that. The spring pusher itself is located right there. You can see that black plastic bit, okay? And then when I depress the gate to open the gate, you can see it's compressing that spring. So the spring pusher itself compresses that compression spring, and that's what allows it to spring back into place. So that's internals of a screw gate mechanism. So that spring pusher, that same thing is happening also in the triple action or our lock safe gate. And Nick or Carson, if you could pull up the image, I believe it's image number 2. It should be a lock safe diagram that's got a green barrel and a separate gate with 2 springs on it. Do you see that? Okay, if we could bring that up on the screen. Yep, perfect. Okay, so we can see there the upper left is the nose slot. That is what closes onto the nose. The furthest upper left-hand spring, that is a rotation spring, and that's what rotates the barrel around the gate. The longer, more open spring that's toward the hinge point, that is called the compression spring, and that activates, that's how we push the barrel away from the hinge to start the opening process. So if I'll do this live now, if you want to cut back to me, Carson. Cool. All right, so here I've got a cutaway. How's that zoom? Is that all right, Carson? Yep. So I'm trying to see, how did we look at that? Oh, this is mirror image for me, but anyway, this is the nose, this is the hinge. And so this spring that you see closest to the nose here, that's the rotation spring. This spring here is the compression spring. So as I actuate this gate to open it, I'm going to push, and I'm compressing that compression spring. And if I let go, that spring puts it back in place. So the first action is push. The second action is twist. All right, and that rotation spring now is what's doing that work. All right, and the little end of the compression spring sits in this little slot here, and that we'll remember that slot later because that's an important point to remember for lubrication. So we're going to compress, rotate, and now as I open, as we saw before, as we open it, that's what's happening inside. So you've got your 3 springs in a lock safe gate mechanism. 3 springs, compression, rotation, and another compression spring with the spring pusher inside the gate mechanism. Cool. That's very fun to see that. So when we talk later about lubrication and cleaning, carabiner maintenance, okay, we'll do a little inspection, but we'll come back to this because I just want you all to really see how fine a machine a carabiner really is. We've got clearances, we've got different springs, we have different rates of rotation, different rates of compression. We have, for this mechanism to work as well, we have gate timing, which if you look at the hinge portion here, we've got some cutaways. That's to allow the carabiner barrel to rotate the way we need it to and stop when we need it to stop. But there's also something to consider here as well, and I'll try to have a little pointer here. Sure, cutting to Nick. Sounds good.
Taylor, man, I just came out of the tree. I was working on this crown reduction. That's cool. The carabiner with the hole in the gate. Never saw anything like that. Hey, I'm going to get back up in the tree here. I'll catch you guys later.
Okay, I'm sure that was entertaining. I couldn't hear it, but so when we talk about the gate mechanism opening and closing, the timing is an important issue, important part of that. So the spring tensions have to be right, the dimensions have to be right. If the spring tension's too tough, it might be more difficult to open. If the spring isn't strong enough, it might not close properly. We also have some dimensions here that are important in timing, and that is, if we look on the frame of the carabiner, this face here, that is just around where the hinge rivet is. So this face is very important, and that coincides with this face on the gate barrel itself. So when we open this, roll this open, okay, you can see that it clears now. Both sides of this clear the frame. And when it closes, okay, as it closes, it begins to rotate now. You can see it rotating around that surface. That element is also very important to proper gate function. If that timing were off and the barrel started rotating too soon, it might snag on the nose. Or if it starts rotating too late, you have other issues with the function of the mechanism. So there's a lot that goes into the design and manufacture of these carabiners. It's really quite amazing. And then we take them and we throw them into the back of the toolbox, or we drop them on the ground and drag them across through the sand, or we never clean them, we never lubricate them. So just keep in mind that there's a lot of fine detail that goes in here, and yes, they're super strong, very robust, but at the same time we have to treat them well. You know, you change the oil in your truck all the time, or you should. Take your truck to the car wash so it doesn't rust. I'm really bad at that. The same thing with, life support, really. Your truck takes you down the road and protects you. These carabiners do as well. So I would like everyone to make a conscious effort to take more time, spend just a little more time each week, cleaning your stuff. Okay. So there's some internals. Any questions on that? Does anybody have anything? When is it okay to use a screw gate? Can they hear you, Carson? No, they can't. Okay. When is it okay to use a screw gate? Well, technically in the arborist world, we don't use screw gates for life support. So really, it's up to you. It depends on where you're at in the world and what your local regulations or national regulations are. For example, in the rope access world, screw gates are commonly used for life support. A self-closing, self-locking, like a triple action or double action, are preferred, but not necessary. However, in the arborist world, we have, I guess, taken it upon ourselves to require that triple action gate for personal protection, right? For PPE. So in the case of a screw gate, I might use a screw gate to attach my water bottle to my harness, or maybe even a chainsaw. I don't even like using screw gates for chainsaws, but that's up to you. It just really depends on where you're at in the world and what the regulations are. That good, Carson? Cool. All right. Well, moving right along, let's get into some of the manufacturing process. Now I have some bits laid out on the table here. I'm going to actually try to bring the camera a little closer, so bear with me for a second while I use my fancy tripod and come down a little bit here and get a little bit closer. And I'll try not to knock this over in the process, but you never know. And I don't think I have anything incriminating on the walls, like a picture of me on the beach or anything. Nope, don't have that. So, welcome to the kitchen. So I've got some missing some bits here, but I have basically the process of manufacture for the revolver rig. This is the finished product. This happens to be a screw gate. I have a lock safe gate around here somewhere, but that's just what I have available in this pack here. So how this all starts out, this is hot forged, as are all of DMM's carabiners are hot forged. It starts out with a piece of aluminum. Now this is just something I took from my dad's shop. I didn't have a sample of the aluminum, but it starts out with an aluminum billet, I suppose you'd call, maybe about this long, right? And this gets set into the forging die, and the press hammers down on that under intense amount of pressure and heat. Boom, and that's what comes out of that. So the first forging, we get this rough general shape, and you can see how it's taken a bar of aluminum and completely changed the grain. It's taken that aluminum and pushed it into all these areas and changed the way that the grain flows through this piece. Very cool, and you can see it's been pushed out, splattered out like that. So what happens? That's the first forging. Now, as to my knowledge, the carabiners just get forged once, but this is a much more complicated piece of equipment. So this actually goes through two forgings, which is interesting. So here's the first forging. Then it gets clipped on the outside and pierced in the middle. And then this gets rumbled in our ceramic rumbling machine to just take down some of the imperfections and that. Then this piece gets put into a new forging die, and we get this, which is much closer now to the finished product. It's got some more detail in it, you can see. And that's really the reason that we do two forgings. It's too difficult to get it down to this in just one hit. So then once this is done, it gets clipped. And I think from that clipping, it goes to machining. I hope I have the process right. Clipped, and then it's machined. So now it gets, it goes from this, we machine that out, we put the holes in it, we machine out the becket, we drill the hinge hole, we drill the hole for the captive bar, okay? Then that gets rumbled to take down all those sharp edges. So this gets put in our ceramic rumbler again. I'm pretty sure that's correct. Then it gets sent off to anodizing. So it goes from a relatively rough looking piece like this, and it gets anodized. And that process is very interesting. I'm not smart enough to talk too much about it. If someone does have a question, I'll do my best to answer. But what anodization, the commercial process of anodization, now we can add dyes to that solution. We dye this to the different colors that we use. You know, obviously here's red. Same thing with green, right? And then after that's anodized, it goes into final assembly. So we get the bearings and the axles and all the other bits, the gate, and that all goes together to make this. And then of course it's inspected at every step along the way. We take samples for hardness testing and all kinds of interesting things. So, and it's laser marked. So and I'll talk about this in a minute. We put an individual serial number on it. We've got the model number, all that jazz. I'll talk about that a little more in depth because it's on the test. So all that process from this billet, just a aluminum bar, forging, clipping, rumbling, anodizing, final assembly, and then we ship it all over the world, and you get to buy it for less than $100. It's pretty amazing, isn't it? Any questions on that, Carson? Okay, cool. We can come back to that if anybody does have some questions. That'd be great. So before I get ahead of myself, let's look at a few. Oh, that's just a sample. It doesn't have any numbers on it, so we'll grab a different one. We'll use the shadow. So on any carabiner, you will see, well, this might be a little difficult. Can you see those numbers, Carson? Okay, that's cool. Yeah, maybe a little more light would help, but at any rate, you're going to have some different numbers and markings, usually on the spine of the carabiner. And we've got here an arrow pointing along the spine that says 24 kilonewton. All right, that's the gate closed major axis strength, or what we would call MBS, which is minimum braking strength. MBS is minimum braking strength. So and it's tested with 12 millimeter pins. So a 12 millimeter pin goes here, 12 millimeter pin goes here, and it's pulled until it's broken. Then the next is that same test, but with the gate open. So we end up either taping or somehow having the gate open. I don't know the specifics of that, sorry. But the same test is then carried out, two 12 millimeter pins to pull along the spine, the major axis, and you get a gate open strength, which in this case is 9 kilonewton. All right. That's a significant difference, right? Significant strength loss, if you want to call it that, with the gate open. So the gate has a very important role to play in maintaining the strength of that carabiner. So 24 kilonewton gate closed, 9 kilonewton gate open. And we also do a cross load test or a minor axis test. And this is done with 10 millimeter pin, to my knowledge. And in this case, that's 7 kilonewton. So cross-loading a carabiner, you get significantly less strength. So it's very important for us to maintain proper orientation of the carabiners, make sure we're loading them along that major axis. All right, different markings there. And then on the spine itself, we laser mark these. Got it upside down. Are you able to read any of that, Carson? Kind of, sort of. All right. Well, the first 4 digits here in DMM carabiners anyway. How's that? A little bit closer. These first 4 digits, that is the model number. So A307. And A is for aluminum, and 307 is the model number of the Shadow lock safe gate. Next is the individual serial number. And the individual serial number consists of the first 2 digits are the year of manufacture. So this is 17. So this is manufactured in 2017. The next 3 digits are the day of manufacture. So 2017, day number 178. And then you get the individual serial number for this particular carabiner is 3937. The last digit there is letter E, and that, as far as I know, denotes the lasering machine that laser marked this carabiner. So, in the serial number, the first 2 digits tell you the year of manufacture. That might be on the test. Next, we go along to the standards that this carabiner meets. All right, so here we've got EN 12275, which is the mountaineering standard for carabiners. And we have EN 362, which is the industrial standard for carabiners. EN 12275 and EN 362, that might be on the test. All right. Any questions there? Still with me, Carson? Okay, cool. And just for fun, this would be this is just a piece of bar stock aluminum. This is about 1/2 inch or so, but it's just what my father had laying around the shop. But this is how the carabiners begin their life. Just bar stock like this. They're bent into a shape and then hot forged, similar to the way that this is done. Okay, there is a slide that shows the Ansi gate testing mechanisms. Can you bring that up? Or the procedure for testing Ansi gates? Cool. And this information is a little bit old. They've updated the standards, so you just maybe disregard the numbers below. I'm not sure if they're still relevant or not, but the test procedure is the same. So when we test the carabiners, as I showed before, we test them along the major axis gate closed, along the major axis gate open, and also cross load from inside out against the gate. And then for Ansi gates, which require higher strength on the gate itself, we do these additional tests. Well, I guess there's really 2 additional tests here. You can see the first one on the left, that's still an outward, cross-loading test. So that would be the same that we do with standard carabiners. But that cross-load test, or I guess they're calling it side load, that is required to be 16 kilonewton or 3,600 pounds, as you can see on the diagram there. And then in the middle section, they lay the carabiner on its side and press down on the gate that way. Oh yeah, minor axis, that's the side load, my apologies. And then of course an inward pushing gate face. So all of those tests have to be done, and that gate has to maintain function. The carabiner can't deform, any of that good stuff. So just some additional testing for the Ansi gates. Now, that doesn't mean that you should load the gate that way in practice. Yep. Say, what is Nick saying? Yeah. So anyway, that doesn't mean that we should cross load that gate or side load that gate. It's there in case, and you know, in some industries they require it. Tower industries, some arboriculture, some tree care companies are starting to require this. I'm gonna not pass opinion on that at this point, but it's just because that gate is stronger, it still doesn't mean that we can cross load it or side load it. We should try to avoid that as much as possible. It's there just as an added precaution. Okay, so don't go out buying Ansi carabiners thinking you can just choke them against all kinds of branches. Okay. Yes. Cool. Yes, hello? Yep, I'm here. Oh, I'm sorry. Hey, Jake, what's it like at the watch party?
Well, Taylor, as you can imagine, we are
All right, I'm pretty sure he said back to me. I couldn't hear a thing he said, but that's cool. I'm glad everyone's excited. All right, well, let's get into some inspection. And I'll try to keep this light and lively. Could you pull up on the screen, Carson, there's the DMM PDF of Carabiner inspection and maintenance? There it is. Might be a little tough to read. I know I can't read it, so I probably won't go through this verbatim. But obviously when we're inspecting carabiners, and I'll just leave this up for a minute while I talk, and then you can come back to me, Carson. But what we have is of course, first off, we're doing a visual inspection. I'm going into a different desktop here so I can read it. There we go. So you've got disinfection and cleaning. You have inspection of the locking mechanism for abrasion, deformity, cuts, sharp edges. Inspect the hinge rivet. Inspect the nose for contact marks, correct alignment of the nose with the slot. All right, and we'll go over that here live on camera. Then we do a gate function check, and we're going to do basically 3 different openings. We're going to open the gate all the way to the spine, and we're going to let it close. And you'll notice there it says release the gate without bias. And what that means is we're not influencing that gate or the barrel with our fingers. We're going to just let it close naturally on its own. Okay, yeah, you can't read that? That's cool. That's fine. We'll show. You can cut back to me. Are you there, Carson? Okay, cool. Oh, it's still funny. It's still on my screen, but that. So I'm going to adjust this. Technical difficulties. 1 second. Yep, that PDF is available on DMM's website. If you just type in, log into the website, go to the website, and just in the search, type in Carabiner inspection, and it should show up. Yeah, it's a good resource to have. Print it out and stick it on your on the workshop wall or the office wall for the crews to look at. So I'm going to get a little more comfortable here. If we look at the test that we're going to do, well, first of all, a visual inspection, right? If I'm doing an inspection here, I'm just looking for dings. I'm looking for chainsaw marks. We all occasionally do that, or handsaw. I see it all the time, or impact marks from the carabiner hitting something or being hit by something. This is obviously a new carabiner. It's quite clean. I've got an older one here that we can look at. And we'll get to that in a second. But the basics are we're checking for visual, any visual cues that something might have gone wrong here. Okay, we're looking for gouges, we're looking for dings, dents, bending, warping, that kind of thing. We're checking for gate function. We're going to check the hinge rivet here for proper function. It's not pulling out or it hasn't been damaged at all. All right, but the gate checks. Now what we're going to do is open this all the way up, and then I'm going to release this without bias. Means that I'm not going to take my thumb off of it and let it roll on the one finger, right? That would be biasing it, or the opposite way. So, and oftentimes you can maybe even just get your finger in the nose slot there. So I'm not even touching the green barrel at all. I'm just touching the nose slot only, and I'm going to let that close. Okay, that's function check number one. That passed. Now, with that, there's a lot of inertia involved, and that inertia can overcome some debris or issues that are going on inside. So we need to do a test without that inertia. So the next test is we're going to pull the gate away from the nose about 10 millimeters, 5 to 10, I think it says on the sheet. 10 millimeters is all right. And again, I'm just going to use my fingernail in the nose slots that I'm not biasing the barrel at all. And I'm just going to let it go from that shorter distance. And what that does is takes away all that inertia, and we get to see how the gate functions when we might, let it go as we're closing it, for example, connecting it to our climbing line or lanyard or something, right? The final check for the gate mechanism will be to open it up, and now I'll turn it around this way so you can see. I'm just slowly closing it until it starts to rotate. The barrel starts to rotate and contact that nose. Okay, and now without bias, letting go at the same time with both fingers, I'm going to let that, see if that closes there, right? Just letting it start to rotate and then close. Let's see if I can do that on a different one. Okay, I will do that. Is that legal? Here again, what I'm doing is allowing, I'm trying to get this queued up, yep. I'm just allowing that to roll, so now it's just contacting the nose. I'm going to let it go, all right? And if it passes those 3 tests, typically I'll just do that twice. I'll go full open, release. 10 millimeter, release. Let it roll, release, and I'll just do that 3 times, or twice in succession. And if I don't feel anything awkward at that point, this gate mechanism is okay. All right. Well, you know what? I'm getting kind of thirsty. I'm going to grab a beer out of the fridge, and I invite everyone watching to grab a beer with me. It's been a long day. Ooh, look at that Modelo. That's going to be tough to do. All right, well, Nick's telling me to open this with a carabiner. Let's see if I can do that. We're going to get it started anyway. and then we're gonna open this puppy with a. Well, heck, we're gonna use a Perfecto. How's that? There we go. Oh yeah, loving it. I'm gonna have to retire that one now. Cheers, everyone. Cheers. Reminds me of being on the beach in Sayulita. Okay, let's continue on our inspection. Now, this is an older carabiner. This is one of mine that I used for a number of years in the field. And you can see it's, the coloring is worn off, the anodizing is worn off. It has some wear marks from rope rubbing on it. In fact, I think this was part of my ascending system. This was clipped into to an ascender, and the rope would rub on this little edge here. And maybe you can see in the camera, you can see it's kind of flattened out a little bit, but still totally functional, no cause for concern in my book. I think this carabiner is perfectly fine. It passes the function tests. Let's just do that real quick. All the way open, 10 millimeters or so from the nose, no bias, let it go. And now we're gonna let it rotate and close. Right? That works. Okay, so, I'm not concerned about any of this. This is, normal dings, normal wear and tear. I can still read the serial number, right? I can positively identify that carabiner. The gate is in good repair. The hinge rivet is in good repair. The timing is okay. Nose slot is clean. No damage or burring. And what we want to look for too is on the nose itself for any excess rubbing or witness marks. As this barrel rotates, it makes contact with the nose there. You can see that, right? So we want to make sure that there's not excess wear of material there. You'll get a little bit of witness mark on the other side, where as the barrel rotates, the barrel is pushing this way, which ends up pushing the gate itself against the frame. All right, but no cause for concern there, but something to keep an eye on. But there's nothing wrong if the anodizing or coloring is gone. I'm not alarmed by any of this amount of wear on this particular carabiner. Of course, I know the history of it. I know it hasn't been run over by a truck or anything, so perfectly okay continuing to keep this carabiner in service. Carson, if you could pull up, there's a screenshot from Rope Lab, Richard Delaney, that has 3 or 4 different carabiners on it. Cool, here it comes. Right. Okay, now this is used with permission. I have Richard's permission to use this. This is he does a fabulous presentation on, well, everything really. But this is a series of carabiners that were pulled at. You can see the different force that these carabiners were pulled to, and they all still passed a function test. That's just a simple straight gate, just one spring gate mechanism. But if you look closely, so one is pretty much untouched, 0 kilonewton. By the way, the MBS, the minimum breaking strength of this carabiner, is I believe 22 kilonewton. So we've got no load on the far left. It was loaded to 17 kilonewton. The second one from the left, and you can see it's just begun to change shape just a tiny bit. Third is 20.19 excuse me, kilonewton, and you can see definitely now it's changed shape. And at the last, it actually pulled greater than its MBS, minimum breaking strength, to 23 plus kilonewton, and these all still function. I attended a workshop that Richard did, and he had these carabiners, and they all still functioned. They passed the function test. So it goes to show, if you didn't know what you were looking at, if you didn't know the model of carabiner, you may very well pass those carabiners on a function and visual inspection. They weren't cracked or broken, but they were obviously deformed when you looked at the new one. So it's important to know what you're looking at, and this is particularly, well, not for your own stuff, but you know, there's lots of tree climbing competitions going on. We have people inspecting gear. You know what you're looking at. Definitely, that's very important. And I wanted to, because I remember that it's on the test now. When is this test available? Can they take this test during the webinar, or do they take it afterwards? And I see my computer's about to die, so give me a second. I'm going to plug it in. Okay, we're back. So MBS stands for minimum breaking strength, but what is the definition of minimum breaking strength? Well, the definition of minimum breaking strength is the load above which a piece of equipment can be expected to fail when it's new, as specified by the manufacturer. So let me say that one more time, because I had some people talking in my ear and I got distracted. Minimum breaking strength, MBS, the definition is the load the load above which a piece of equipment can be expected to fail when it's new, as stated by the manufacturer. So this shadow carabiner here, MBS is 24 kilonewton, gate closed, loaded properly. We can expect at or above 24 kilonewton, above 24 kilonewton, we can expect that this piece of equipment will fail. Okay, so that's the definition of MBS. Trying to think of anything else I need to cover. There are a few things on the test. You might have to visit the DMM website to look up some information, but that's kind of the point. So, lubrication and cleaning, Carson? Yeah, we're getting to that. How we doing on time? We got like another 40 minutes or so? Okay, cool. Oh boy, I'm so thirsty. It's really hot in here. That fire is really roaring. Okay. So I suppose at this point we can get into some cleaning. So why don't we do, I'll do a live cleaning demo, and we'll take any questions there, and we'll talk about lubrication after that, and then we'll close out, we'll finish up. So come with me over to the kitchen sink. I'm sure Aisha will be thrilled I'm cleaning carabiners in the sink, but no big deal. I did the dishes. All right, let's head over there. How's that shot, Carson? That'll be all right if I just work right here like this. Okay. Gonna plug my computer back in. Awesome. Okay, so rule number one, I'm just going to clean one carabiner here, and this actually still, it's just a little barely sticky on the slow roll. But this is just one carabiner. I like to clean several at a time. I usually have a bigger bin, fill it with water and a little bit of soap, and away you go. So rule number one, not hot water. We want lukewarm, no hotter than 25 degrees Celsius or 77 degrees Fahrenheit. So it's really just a little, it's tepid, a little warmer than room temp, And the reason for that is there's, well, a couple things. There's that spring pusher, that little plastic bit in there that you saw pushing the internal spring. Grab it. So there's a number of reasons why we don't, boil carabiners or anything like that. And number one is that there's some plastic parts in here. Only one in this case, but you don't want to heat up and deform that plastic part. So it's best to use, it's imperative to use lukewarm water. Oh yeah, sorry. Laptop moving. I think I can set it on the floor and it'll be okay. There we go. I'll try to keep my head out of the way here. So what I'm going to do is just get a little bit of water going here. I'm not going to use a thermometer. I'm just, for this purpose, I'm just barely warm. All right, a little bit of water in a bin, get the carabiner soaked in there. I'm going to add just a touch of mild detergent. So this is, unscented, free and clear, whatever. I'm just putting okay, that was too much, but whatever, that'll work. So, and I'm going to agitate that, get some suds going. Right, agitating the carabiner in there, and what that's doing is allowing water and the suds hopefully to flow into where those springs were. All right, and then I'm going to activate and actuate the gate mechanism in the water. Okay, everybody can see what I'm doing here. Is that a good shot, Carson? Sweet. He says I'm killing it. So, and already I can see debris. I'll try to get a close up of this water, but already I'm extracting debris out of the gate mechanism. So I'm just going to do that back and forth a few times, right? And if I had a few more, I could. Yeah, this is laundry soap, and it's. I mean, this is not an official recommendation. This is just what I use. Generally, this is just some organic, hoity-toity, free and clear, natural detergent for sensitive skin, because I have sensitive skin. All right, that's fine. I mean, a little bit of, dish soap. What you don't want to do is put some industrial cleaner in there. We want something mild with a neutral pH. So it's, and we don't want any solvents. We'll talk about that too. I've had people using brake cleaner, gasoline, all kinds of stuff. That can be very harmful to the internal mechanisms. Okay, so no brake cleaner, nothing harsh like that. Brake cleaner is extremely drying, and the same thing with gasoline. So there's no need to use that stuff. Just a mild soap, mild detergent. I've even washed carabiners with hand soap before. Just some, because I like my patchouli scented soap. I like my carabiner smelling fresh. So, all right. I'm gonna very quickly grab that that cutaway so we can just see what's going on as we're cleaning. So obviously, as I get this wet, There's going to be water and soap is going to be allowed to go inside here in the compression spring along with the spring pusher. So another reason we don't use hot water or harsh chemicals is due to the spring pusher, and also there's a little bit of grease. When we assemble these, we assemble them with a little bit of grease. It's preservative, it's lubrication, and we want that grease to remain in there as long as possible as well. So no harsh cleaners, no solvents. But you can see that as I'm actuating that in the sudsy water, I'm moving the springs around, I'm getting things to flow through there. It's in the tree world, for sure, how many times have you had some bark, a little chunk of bark gets jammed down in there, you get some leaf debris jammed down in here, okay? And that's what I've been doing by agitating that water and opening the gate mechanism in the water. I don't have to pretend, I can just do it, right? I'm flushing that water through there. And another thing we'll talk about a little bit later in lubrication as well is you can see the compression spring here butts up against a little stop or a little wall. And that divides the compression spring from the rotation spring. So if we're just adding lubricant to one side, we may not end up getting both springs lubricated. So we'll talk about that in a minute. So agitating that underneath in the water, and then I'm going to take my this is Aisha's toothbrush. I'm going to take that, and don't worry, I'll bleach it before I put it back in the bathroom, honey. All right. So maybe you can see there's a little bit of buildup. There's some debris around the hinge rivet there. Can you see that all right, Carson? Okay, cool. So I'm gonna just take a toothbrush and I'm gonna get in there like so. I'm trying to do this like upside down backwards to get it for the camera. I'm gonna rotate around and I'm gonna dig in there, right? And I'm dip it back in the water, flush that stuff off. Okay, and I'm doing this slowly and deliberately. It doesn't take this long once you get used to doing it. All right, but I'm not gonna get too crazy with the spring pusher, right? I'm just gonna get a little bit of the debris out of there, but I'm not gonna jam anything in there. I'm not gonna pick away or scrape at that spring pusher because we don't want to disturb that. So there, see, check it out. That little piece of debris just came out of there. Right? I mean, that's something that easily could get run down and stuck underneath that compression spring, and that'll slow down that gate mechanism and cause it not to close. So this is what we're going after, right? Just little stuff around the hinge just to clean it up. We're going to rotate that open. We're going to pull it down, right? We're going to get both sides of it, okay? We're going to do the same on the other side. We're going to open it up. Right, we're going to clean the nose itself. If there's any debris stuck on the nose, that could be sap, pine sap, conifer sap. We're going to clean in the nose slot. All right, this is a little tough for me to show, but like the nose slot here, okay, right? I'm cleaning out any debris that might be in there. All right, get it under the water. Give it a quick rub down, okay? I'm just gonna actuate it again a few more times. All right. Okay, that should be pretty good. This one wasn't incredibly dirty. Okay, now I'm gonna rinse it. Move the camera just slightly. I'm gonna rinse this in just fresh water, cool fresh water right now, just quickly. I'm gonna actuate that gate mechanism again. So that's kicking out any debris. Oops. Get my computer wet, the camera wet. All right, that's it. That's clean. Now we have to dry it. And normally what I would do, I'm not at my father's shop, but I like going there because he's got an air compressor, and I just use a little bit of compressed air and blow this out. You don't go crazy jabbing things in and super high pressure. But at any rate, right now, I'm just going to use paper towel or two. Cool. We're breaking for breaking news. We'll be right back.
I'd like to first give this award to my good friend Taylor Hamel for his expertise and knowledge in helping the country learn more about carabiners. It's an important subject. Taylor, you get the National Golden Carabiner Award on behalf of a grateful nation.
Okay, I don't know what that was all about, but hey, there you go. I don't have any. Thank you very much. I don't have any audio, so I can't hear what's going on. Anyway, here we are back again. I'm just, drying this out the best I can because I got to get back in the field, right? I would let this hang overnight, I might hang it on my little drying rack, let it hang overnight. That's perfectly okay. But even as I'm actuating it now, it's ejecting some of that water. So I just want to get it as dry as possible. All right, and I don't have any compressed air here, but what I'm going to do is hit the gate mechanism with compressed air, and I'm going to get into the, let me try to find a pen here. All right, I'm going to, question? Sure, go ahead. Negative. Okay, the question was, if the spring pusher wears out, can it be replaced? And that is no. I'm sure it's possible, but we would not do that for a used carabiner and send it back out again. So if your spring pusher it becomes damaged or wears out, as it were, yeah, that's just time to use that carabiner for other functions or stick it on the wall and retire it. Any other questions, Kale? Sorry, Carson? All right, so I'm just drying, but with compressed air, I'm not going to go crazy, but I am going to try to shoot into these little places where we'll get to those springs. So I'm going to shoot a little compressed air in here. I'm going to shoot a little compressed air down this portion. I'm going to swing it open and shoot a little compressed air. Just like I said, don't go crazy with it, but that helps dry it out. Compressed air is very dry, and we just want to remove that moisture before we lubricate it. So assuming that we've done that, now we're gonna go for lubrication, and this is important. And there's been some misinformation, or I don't know. There's just been generally accepted the generally accepted practice of using graphite powder, and I'm going to try to get in shot here, so I'm not talking to Noah. Oh yeah. So there's been some misinformation about graphite powder, and graphite powder is not good in a gate mechanism, and there's a few reasons why. And this will also be on the test. And maybe I should look at my notes, but if you think about what graphite powder is, let me back up 1 minute. If we look into, you saw the debris that was coming off of my, coming out of that carabiner, and if I can dip down in here, I'm not sure if you can see, Carson, can you see the little bits of floating debris in there? Or is that not really working? Yeah, from my perspective, there's quite a bit of debris in there. And that's exactly what we're trying to do, is remove that debris. And what graphite powder is basically really fine debris. If you think about how we want this spring to work and how we want that spring to glide along the gate, and we want the barrel to rotate and all that, we don't want any debris inside there. So what graphite powder does is not only is it technically it's debris in itself, and I'm not talking about for your car lock or something like that. I'm talking about for carabiner mechanisms. Graphite powder is perfectly fine for other applications, but not here. So what it does is it builds up. It's difficult to apply in a controlled manner. It ends up building up in those hard to reach places, right? And it's difficult to remove. When it gets wet, it creates a sticky paste. That's very difficult to remove, if not impossible. You know, externally it's fine, but when it gets in here, it builds up and builds up and builds up, and eventually the spring can't function anymore. All right. I'm trying to think of what else I said on the test about it. It does not help to dislodge debris. And what we saw here is that little bit of cleaning that I did dislodged that debris. And when I add oil to this now, a good quality oil, lightweight oil, I hear it a lot. Well, you're not supposed to use oil because it attracts dirt. Okay, but graphite powder is basically just dirt. Okay, so yes, I mean, anything wet will attract dirt. You know, if you put water on your finger and you stick it in some soil, you're going to come up with some soil. That's just a fact of life. But what good quality oil does in a gate mechanism is it moves in and penetrates those hard to reach areas, and it tends to suspend particles and move them away from those areas that need that lubrication. So oftentimes when you oil something and you actuate it, so oil the gate, actuate the gate, you'll see particles, you know, just coming away from that mechanism, right? And oftentimes I think that's what people mistake for, oh, it's attracting dirt. But when actually it's expelling dirt, right, or debris. So something to think about. You know, we use oil on our hinges, we use oil in our cars, and we have filters, and we change the oil regularly. It's the same thing with the Carabiner gate mechanism. It's not just maintain it once and forget it. It's a regular process. So make sure that you're doing this regularly, or at least, you know, when it needs it, right? But you shouldn't be, oh man, this gate's getting kind of sticky, and leave it for another week, and then, oh man, it's really sticky now, like I have to physically, you know, and before you know it, you've been climbing with a sticky gate for 3 weeks when, you know, it just takes 5 minutes of your time to clean it and lubricate it. So lightweight oil. Now, if you pull up on the screen, Carson, there's 2 pictures of oil. There's duck oil and 3-in-1. If you could bring up the duck oil quickly. Yep, no worries. Cool. So this is duck oil, and if people get confused by this, it doesn't come from ducks. It's just a name, or people are just having fun with it all the time. But at any rate, this is available in the UK and in some parts of Europe. You basically cannot get it in the US or Canada, as far as I know. So just don't worry about it. But duck oil is an oil that DMM has, you know, investigated and done some testing on, and we use it in certain applications. And so officially, we would recommend duck oil. But if you can't get duck oil, you can use a widely available oil, which is 3-in-1 multi-purpose oil. And if you can switch to that, it's readily available in every hardware store around the country. So there's different kinds of 3-in-1 oil. So look for the multi-purpose oil. Okay, 3-in-1 multi-purpose. And even 3-in-1 might not be the best and greatest oil out there, but DMM has done some testing on it, and we're happy with what it does. We continue to investigate new oils, and thank you. We continue to investigate new oils in that, and you know, we'll let you know how it goes. But really, we only know so much about what's out there, and you know, we can take the time to test and do some things, and you know, it takes time as well. You know, how does this oil behave after 16 months of use or whatever? So so for now, you know, a light quality, in quotes, oil, you know, 3-in-1 is okay. There might be something better out there. A sewing machine oil, you know, gun oils, lightweight honing oils, things like that. Just, you know, lightweight without any harsh additives or crazy, you know, who knows what in it, you know, you should be okay. So We would we do not recommend WD-40. WD-40 is well, WD, I guess, stands for water displacement, right? WD-40 it's very drying, actually, and it works in the short term, but over time, you're doing yourself a disservice. So no WD-40, certainly no graphite powder. Stick to duck oil if you're in the UK, or 3-in-1 oil, or a similar quality lubricant is totally fine. Yeah, gun oil I think would be fine because it's meant to work in mechanisms and springs and the slide of the frame. Bar oil is a bit. I would not recommend at this point. I don't know about bar oil, but I would say no. I would not recommend bar oil. It's too viscous. The whole point of bar oil is it's supposed to stick to the drive links, so I would not recommend bar oil at this point. That there might be a different statement officially, but let's leave bar oil out of it. No motor oil or bar oil in carabiners. Now we do use motor oil, SAE 30 motor oil in our bushing products, like the bushing pulleys, like the Hitch climber and the Pinto, standard Pinto, and also the impact blocks. We use SAE 30 motor oil because that's what the bronze bushings are impregnated with, but that's a different webinar. So for now, we're going to stick with 3-in-1, and I'm going to show you just how little oil it takes to get this functioning again. So this isn't completely dry. I'm just doing this on the fly, but we've dried this overnight, or we've used a little compressed air to dry this out. And this is my procedure. So what I'll do, this little slot here that captures part of that rotation spring, right? Well, that opens up right down into that rotation spring there. Okay, so in that little compartment, you notice this wall here is separating the two springs, right? So I'm going to take one little drop of 3-in-1 oil. I'll try to get this on camera. Into that slot there. Boom. That was just one drop. And I don't know if you caught that, but it wicked into that spring. So I just dropped the oil on the surface and it wicked into that spring, and now it's probably most of the way around that spring. So there's one drop of oil there. I'm gonna come to the hinge side. I'm gonna pull down on the mechanism, and actually I can still see a little debris there, so I'm just gonna kick that debris out of there. All right, so now I'm in this position. I'm gonna pull down, and I'm gonna just put one drop there. Okay, one drop only. Go to the other side. Pull it down, maybe rotate it just slightly. I'm just gonna put one drop there. Okay. And if I need to, I can also stick a drop up here to get the hinge pin, right? But this is feeling pretty good right now. So so far I put 3 drops of oil in this carabiner, just 3 little baby drops of oil. And now I'm going to actuate the gate. I'm going to hold it away from the camera in case it splatters, right? I'm just going to actuate it, kind of use that inertia to get that oil spreading and coating those springs. Okay, and last, this isn't entirely necessary. In some cases you may want to do it, but I'm going to open up this way, and now I can see down into that compression spring, and I'm going to put one drop of oil in there. Okay, just one drop. Actuating it. One final little rub down to get rid of the excess. Paper towel isn't maybe the best idea there. There we go. All right, that's it. Go ahead. All right. I'm throwing this to my friend Sean, who has a message. Here you go, Sean.
Well, as many of you know, I've been the sexiest man alive for many a year. You know that. But no one, I think we can all agree about that, is more sexier these days than Taylor Hamel. So I want to pass this along to all of you here in the room, you're listening, passing it along to Taylor Hamel for sexiest man alive. The torch has been passed.
Oh, thanks. Thanks, Sean. I appreciate it. I'll put that in my pocket. Awesome. All right, so there we went through the cleaning process. A little bit lengthy in explanation, but really it only takes a few minutes. Dry it overnight. I used 4 drops of lubricant. And even that, well, we'll just leave it there. I'll go through a few little cleaning, a few finer points of cleaning, extra tough carabiners in just a second. But as we can see now, carabiner, I'll do the function checks again. And it's working. Oh, there I biased that. That was my mistake, right? Now I'm going to let it touch the nose and close. So that carabiner is good to go. All right, let's talk briefly about well, first let's talk about pine sap. I've worked in conifers quite a bit, and not as much as some of the folks in the Pacific Northwest. You climbers out there are true champions of conifer climbing and probably carabiner maintenance, because completely covered in conifer sap, and if you get it inside the springs, you're asking for trouble. So one thing, what we don't want to do with that situation is boil. We don't want hot water. Hot water, yeah, it loosens up the sap, this and that. We don't want to put the carabiners in hot water. So A, don't do that. What will work to get conifer sap loosened up and off the beaners is vegetable oil. So canola oil, I think, in my personal experience, sunflower oil and olive oil worked really well. But it's totally okay to just drop that carabiner in a little dish of vegetable oil and just allow it to soak, maybe even overnight. Get in there with your toothbrush, right? Start scraping off all that stuff. Maybe soak it again. It's a longer process, but eventually you're going to get to the point where it's relatively clean, and you'll just go through the cleaning process that I just described and lubricate it as normal, and that should get you back to working to a working gate mechanism, even when it was heavily contaminated with pine sap. If it doesn't work, just keep going. That it just means it's been built up, and hey, eventually at some point you got to retire a carabiner, and that might be the way it goes. We don't have a stated lifespan on our products. Some textiles might say 10 years or 5 years or 8 or whatever it is. There's no stated lifespan on hardware at this point. So you can continue to use these for a long, long time. Just clean and maintain them. So a couple points about, say you've cleaned your carabiner, you've gone through the lubrication, everything, you did it the way I just described, and it's still not quite right. It's slow to turn over. It's just feeling sticky. Well, what I've found in that case, usually what happens is you've got a piece of bark or a piece of leaf or something that's jamming in the springs. And really the only thing to do there is just keep getting it wet and keep soaking it until that breaks up, and just keep going through that cleaning process. But something that I found that works really well, when I found that I have a carabiner that I cleaned it and man, it's just still not right, I'll flood it with oil. So I'll take my 3-in-1 and just go to town. I'm not going to do it here. I'll put the cap on, but I'm going to just over the garbage or the sink or wherever, I'm going to activate this gate mechanism, and I'm just going to flood it with oil. Just go crazy with it. Flood it. Let it sit for a little while, and then go through the cleaning process again, because you don't want too much oil in there. It just creates a mess. You know, I'm already getting some on my fingers here. You don't need that getting on your ropes and stuff. It's annoying. So just flood it with that, with lubricant, and then go through the cleaning process again, and just drop your 3 or 4 drops of oil, and that should usually do it. So a tip. Cool. Awesome. There's a tip for really tough carabiner cleaning issues. And let's see. I'm going to check my notes. That's really about it. Does anybody have any questions? Kale or Nick, do you think I missed anything? I'm going to go off camera just for a second here, grab my notes. There are a couple things that I did want to mention. We'll go, I think we'll just stick here for now. This is fine. We'll finish up at the kitchen sink. I'm going to raise this up just a little bit so I don't have to crouch down. Okay, so we talked a little bit about minimum braking strength, right? We talked about MBS, and when the carabiner is loaded in the test rig, you know, we load it with 12 millimeter pins, and we pull it along the major axis like that to get our overall MBS. Now, improper use or improper loading of a carabiner will reduce that number. As we can see, when we cross load the carabiner, we get a reduced braking strength. If we, for example, were to side load the carabiner across a branch or something, we get a reduced strength. The gate's not meant to take that impact. And another thing would be loading closer to the nose. We talked about this earlier. You know, these carabiners are designed generally to push the load closest to the spine. So like, for example, this carabiner, if I were to load this carabiner at the nose, you know, from the basket here to the nose, I would get a significantly lower braking strength versus if I were to load it back here at the spine. Okay, so it's important to keep your carabiners configured correctly. Having said that, the ovals, the Ultra O carabiner, or the Perfecto, our new Perfecto, this carabiner is designed to push the load toward the center, okay? And that's perfectly fine because we've designed it to do that, or, you know, just the shape itself. I mean, it's an oval shape. It works well to centralize that load, and that is where the pins sit when it's tested, right? If I could get the pin to sit closer to the nose, I may get a lower braking strength, right? But that's hard to do, which is the beauty of a symmetrical oval, is that it centralizes that load. No, I don't have it with me. Sorry. Okay. Cool. Yep. I'm just going through making sure I covered everything that's on the test. And okay, I think I'm good. Thank you everyone for hanging out with me and drinking a beer. and learning a bit about carabiner maintenance. I hope it was informative. I had a lot of fun. Thank you so much to Nick and Carson, Jake, and Kale at TreeStuff for putting this on. Really appreciate it. And we're going to cut to Nick. And thanks, everybody. I'll see you later.
All right, well, thank you, Taylor. You got my mic, Carson? Yes. Thank you, Taylor, and thanks to the audience for watching. That was a riveting hour and 40 minutes, 2 hours on carabiner maintenance. I learned a ton. I thought the cutaways were especially cool with the holes in the gates. That was definitely stuff that we hadn't seen before. Please stay tuned. There's going to be something very special for you right after we wrap here on the video, so don't leave. There might be a drum solo or something like that. And then you'll also get the test link. The quiz link will be coming up in the comments for this page, as well as in a separate post on the TreeStuff Facebook page. So that'll be coming up in the next couple minutes. As always, I'd like to thank the crew here at TreeStuff. Carson Royer, my right-hand guy, he's on the production booth tonight. Kale is at home. He's a little sick, but he set up all of the digital assets for us. And Jake Miller, the new guy on our team, did some of the funny voices that you saw tonight, as well as helped get all this plan and all the logistics set up. So a big thanks to those guys. We definitely couldn't have done it without them. Oh, come on, guys. I was in the nice rainforest.
Thanks for watching. Oh, I'm screwing up now. Later.